And so we do. We add the sine of 30 degrees plus 45 degrees. And if we were to use the formula, guys, you would realize that you see here the sum of mu sub v. So I'm going to go ahead and label this as mu, and this one, or u, and label this one as v. And now we go ahead and use that to expand it out. So it's the sine of 30 times the cosine of 45 plus cosine of 30 times the sine of 45. And now we can use our square root trick or hand trick. Kind of cheated here and went ahead and gave you this, which, whatever. But the idea is that won't be there for you. So the idea is, can you go ahead and find out what the sine of 30, cosine of 30, sine of 45, cosine of 45 is? So what is the sine of 30? Say it. Say it louder. 1/2. If you look here at 30, sine is what value? Is x or y? And so it's 1/2. So sine of 30 is 40. What's 1/2? What about the cosine of 45? Square root of 2 over 2. Plus, well, if the sine of 30 is 1/2, what is the cosine of 30? Why do you think I asked it that way, guys? Why do you think I prefaced the value of the sine of the angle before I asked you what the cosine is? They're together, right. Look at cosine. Look at 30 degrees. What's the y value? What's the x value? All right, go look at 60 degrees. What's the x value? What's the y value? Go over to 120 degrees. Look at the x and y. Look at 150 degrees. Look at x and y. Look at 210, 240, 300. Y'all see what I'm talking about? Every time you take the sine of one angle, the cosine is going to be the other value of that same angle. You know what I'm saying? So they always go together on that one. And that's just a way, guys, and I'm using that just a way to help you work these problems easier. Don't, for the most part, be safe about it, but hey, if the sine is 1/2, that means the cosine is going to be root 3 over 2. And of course, 45 is always going to be what? And there you go. And now we multiply those. So, Sophia, you good? Okay. So let's figure out the first product. What is 1/2 times root 2 over 2? Say it. Square root of 2 over 2 times 2 is? That's all right. Somebody's answering. That's fine. Right or wrong, I'll take it. So remember, guys, when we multiply fractions, you just multiply across. 1 times root 2. Root 2. 2 times 2. 2. Now when we add, which we're about to do, denominator stays. Let's go and do the other product. Let's see, what is root 3 times root 2? Root 6. And of course, again, 2 times 2 is still going to be 4. And now we need to add them together. Good thing is what? They have the same denominator, so what does that mean? Just put the top together? Well, they're not like terms, so you have to keep them separated. And there's your answer. So you find out what two angles add or subtract to get you that 75. Then you use the formula to go ahead and expand it, and then just find the values from there. Hand trick or square root trick, whichever one. All right? What about cosine? What about 15 degrees? We do cosine. Could I do 240 minus 225? Yes. Could you do 225 minus 210? Yes. As long as you get 15, we don't care. I don't know why you'd want to do that, but you can. I just always recommend first quadrant, which I know I'm going to tell you guys, I'm going to sell this to you. You already got it. First quadrant's nice because you don't have to worry about any signs, whether it's positive or negative. JC. All right. So let's go ahead and use the formula there. Cosine of differences. We're looking at this one here. This is U, this is V. So, cosine of 45 times the cosine of 30 plus sine of 45 times the sine of 30. Cosine of 45? Root 2 over 2, good. Cosine of 30? Oops. Plus, what? We already know the sine of 45. And we just found the sine of 30 earlier. What's root 2 times root 3? Root 6. 2 times 2? Hey, this is all looking very familiar. Yes, it is. It'll always be root 6 and root 2 at the ends. Now, from there, it's different. Positive or negative, we don't know which one's what. Just depends on what angles you're picking. Now, if we picked 240 and 225, we'd be multiplying two negatives together to get positive, so you get the same answer. However, if it's a different angle that we're trying to find, so if I'm using 60 minus 45, you still get the same thing, guys. You still get the exact same thing all the way through. Wait, does that mean that the sine of 75 is the same as cosine of 15? Do y'all see that? Would you agree those two numbers are the same? Yeah, they're out of order, but they're the same number still. They still have the same sign. Root 6 still positive, root 2 still positive, right? Both over 4. Do y'all agree with me? So how is it the exact same value? Can you do me a favor? Look at the sine of 30 degrees. Go look at the cosine of 60 degrees.
So is it complementary angles add up to the same like cosine sine?
Yes, complementary angles. 1575 was complementary.
And those add up to 90?
Add up to 90. Those two angles, if I take the sine of one and the cosine of the other, they'll be the exact same. So the simple one to see, of course, is the easy one is this 45. Sine of 45 is the same as cosine of 45, right? Well, yeah, because that's in the middle. Sine of 30 is the same thing as cosine of 60. Follow me? And vice versa. And we're going to do the same thing all the way through. Any combinations that are complementary, you'll always get the same answer from sine compared to its cosine, and vice versa. Okay? So yeah, you should get the same answer because 15 and 75 are complementary. So therefore, the sine and cosine of each one should be equal the same. All right? Sine of 105. 45 and 60. 135 and minus 30. You have different versions of it, right? So let's do the 45. You know what? Let's do the minus because we haven't done difference in signs. We've only done the addition. So let's do the sine of 135 minus 30. So expand sine out. And so what's the formula there, guys? I don't have it handy. I don't memorize it. Oh, what's u and v? It's u and v, right? Sine of u, cosine of v. Minus, what's the minus again? Cosine, sine? So the sine of 135. Well, let's find the reference angle first. So for 135, how many degrees does it take to get down to the x-axis? 45. So what's the sine of 45? Square root of 2 over 2. And then, what quadrant are we in, guys? Second quadrant, so sine is going to be positive or negative? Positive. All right. Cosine of 30 is... Oops. There we go. Cosine of 135. Again, the reference angle is 45, which means that the value is going to be what compared to sine? The negative of the sine of 135. Oops, and this one's 1/2 here. Multiply, so root 2 times root 3. That's familiar. Negative root 2 times 1, and then it's a minus. So what do we end up with? Plus root 2 over 4. Well, great. We've done 3 different problems. We end up with all the same answers. What is the reference angle to 105? What's the reference angle of 105? 75. Therefore, the sine of 105 is going to be the same thing as sine of 75 because it's a reference angle. And all we got to do now is 105 is in what quadrant? 2. Okay, be careful with that. Hang on. You're using the complement rule. You're using what we talked about earlier, Mary. You're just getting those complicated. Watch this. 105, Mary, puts us right here. Remember, when we find the sine of any angle, we always have to use its reference angle. Finding the sine of 105 is really hard to do. What we can do is, that's 75 degrees. Because you have supplementary and complementary, right? Supplementary is what's going to help you with the reference angle. But here's the deal is, the sine of 105, that's supposed to be a 5. It looks like an 8, but it's a 5, is the same thing as a cosine. Well, no, that wouldn't work either because it's not complementary. We've already passed the 90. The sine of 75 is going to be the same as the cosine of 15 because those are complementary. they add up to 90. Okay, so that's the reason why we got the same answers there. And so it just kind of explains, guys, why we're getting the same answers going through is 75 and 15 are complementary. So the sine and cosine are the same. Sine of 105 and the sine of 75. Well, 105 and 75, the relationship is 75 is the reference angle to 105. That's why it's the same. It's the same reason, guys, why we get the sine of 135 compared to the sine of 45. Because the reference angle to 135 is 45 degrees. That's what I had you find. Now the good thing about this, why it doesn't look any different at all, is because 105 is in what quadrant? 2. Sine is it positive or negative in the second quadrant? Positive. When we did it for 75, guys, what did we end up? Positive or negative answer? Positive, so it all fits. See, same idea that cosine and sine and tangent are going to have like, I hate using signs because that's the name of the word. Anyway, here we go. Find the exact value of the sine of 42 and the cosine of 12 minus cosine of 42, sine 12. So go up to the box, look for this in the equation part, and tell me, is the sine or cosine sum or difference? Well, it's going to be sine because I know that these are different trig functions. Cosine has the same. And its difference? To be thorough, I'm going to go ahead and label the u and v. So now I'll go ahead and say it's the sine of u minus v. That's straight from the formula. Well, u is 42 and 12 is v, so... Oh, sorry, Adrian. Didn't take it from you. Could have saved you a trip. Well, what is the sine of 30 degrees? How about the next one? That's it. That's the answer. Well, I noticed that both the trig functions are the same, so it's going to be a cosine. And of course, cosine always has opposites, so it's going to be the sum of the two angles. Bless you. So what's the cosine of 90? All right, on to class practice. All right, front column, do number 1 and number 5. Only. We don't do more or less. 1 and 5. Second column, 2 and 6. Only, not more or less. Third column, do 3 and 7 only. Fourth column, do 4 and 8 only. Please. Once you get it, please put your pencil down.